Welcome students in the class of Coherent and Incoherent edition of Wave of the chapter Wave Optics from the class 12 Physics, which is an important topic for the CBSE NEET as well as for the IIT JEE aspirants. Let's begin the first topic, which is our wave optics. So, from the basic theories of a light, what we know, firstly we understand like from the Newton's theory that light is the form of a corpuscles or a corpuscular. Then wave theory came in the nature. After that, quantum theory, then dual theory. So what we are studying one by one, like earlier we were studying in the ray optics wave theory, corpuscular theory, and now we are going ahead with the wave theory. So wave theory characteristics are few things like they explain the properties of a light reflection, refraction, polarization, interference, and diffraction. Interference and diffraction. So what is the meaning of interference and diffractions? Concept of a superposition, interference, and diffraction. These three things basically we are going to explain. So firstly, one by one, we will understand one like each and everything. The first one is the concept of superposition of waves. Consider a particle P in a medium. If wave of amplitude A1 arrives at the point P, students, I think you are able to understand. The point is again A1 if arrives at the point P. Now, if another wave amplitude A2 arrives at the point P, so now as you see, if both the waves simultaneously arrives at both the point P, what will be happen? The amplitudes of both the waves increase. So the resultant wave will be the maximum amplitude. But the phases are same. So let us consider another case where the first one is the upper height, or we are saying that the high peak, and second one is the low peak. As you can see over there, students, this is in a high peak phase and it is in lower peak phase. So for that scenario, if both these waves are simultaneously arrives at point this, so first line we will get the resultant wave in a straight. So for that scenario, if the amplitude of anyone is a higher, so we will get resultant wave in a lower wave. Students, if you have any doubt or ask any questions, you can ask in the chat session. Students, as you can see over there, what we have taken, I just want to elaborate more. In the first section, we had just taken the maximum amplitude with the A1. In the second, I'll just take a wave with the A2 amplitude with the lower amplitude. The resultant amplitude will be this. As you can see, they will cancel out. Cancel out their nature each other because the A1 and A2 both are in the opposite phases. So resultant we can find out by the A1 minus A2. Same phase and opposite phase. In the same phase, resultant waves amplitude must be added, like A is equals to A1 plus A2. But as you can see over there, students, in the opposite phases, what will be happen? Yes, the amplitudes are subtracted, not added. In both the scenario, what we get in the concept way, the first concept which we understand, the resultant waves amplitude is a maximum when the waves phase are same. And we can say in the same phase, waves are a resultant waves are more perturbed than the opposite phases. Second scenario, which we realized that in the opposite phase, resultant waves are less in our amplitude, and because of that, disturbances are less. So The momentum and the energy which they are carrying actually that is also less. This concept or a phenomena of more than two waves simultaneously arriving at point was firstly introduced by the Huygens, and we get a resultant waves is called as concept of superposition. So what we are taking as students, we are just taking two types of a wave and we are just superimposing. We are just trying to relate the concept between two waves, like if they are same phase, if they are in opposite phase, if they are in the like pi by 2 difference phase. These kind of things we are just taking by the experiment, and we concluded a resultant wave which is actually propagating in the medium. For that medium, students, that is the resultant wave is responsible for any other disturbance. So that concept we are taking for the superposition, that's related with that. Now move some MCQ questions so that clearance should be more. When the two waves superimpose in the same phase, the resultant amplitude is A1 plus A2, A1 into A2. A is equals to A1 minus A2 and A is equals to A by 2. Students, I think this is so simple question. If you understand the previous concept, quickly you will be able to give the answer. And the answer is yes, A is equals to A1 plus A2. Next question we have, when the two or more than two waves arrives at a point simultaneously to get a new resultant wave, the concept is called as a reflection, polarization, refraction or superposition. Students, I hope you remember that superposition is a nothing but the relation between two waves. So we can say that we are just adding two waves in the form of a different phase and in the form of a same phase. And we are just seeing the relation. For that, this phenomena is called as superposition. So when two or more than two waves arrives at a simultaneously to get new resultant wave, the concept which we are called as a superposition. Now, next we are saying like what will be happen? What will be actually the mathematical form of a superposition of a wave? In this phase, phase difference will be zero, means they are in the same phase. So when two waves arrive simultaneously and they have a same phase, for that scenario, amplitude will be maximizing. The amplitude of the resultant waves is given by vector addition, that A is equals to under root A1 square plus A2 square plus 2A1 A2. So as we know that phases are same, so theta will be 0. So for that scenario, amplitude of the first wave is equals to amplitude of the second wave. And theta will be between the phase difference between the waves. So we just put all these value here, A1 plus A2 because of a cos. We are just taking cos 0, so cos 0, 1. This is the formula for A1 plus A2 whole square. So amplitude will be A1 plus A2. And if they are in the opposite phases, students, things will be continuously changes. So when they are in the opposite phases, so that time theta is equals to 180. And in the case of a 180, cos 180 is equals to minus 1. So we just put the resultant formula, which is A is equals to A1 square plus under root A2 square plus under root 2A1 A2 cos theta. And here is the theta is equals to 180. So what we have to put? Yes, we have to put just a square plus b square, that means a2 square plus 2a1 a2, that means into multiplied by minus 1. So that answer relation comes in the negative era, that a1 is equals to amplitude of first wave, a2 is equals to amplitude of second wave. Phase difference between the waves, theta, will be responsible for that. So theta is equals to 180. We just put this value and get the result A is equals to A1 minus A2. I hope students you are understanding what I told and what I am explaining. Now the next thing is the principle of superposition of waves. Like in which principle superposition of a wave actually exists or comes in the nature. When two or more than two waves arrives at a point simultaneously, then the amplitude of a resultant wave is given by vector sum of all the amplitudes of each of the waves. So the resultant formula which we are calculating or which we are taking, that is A is equals to under root A1 square plus A2 square plus 2A1 A2 cos theta. Move on the MCQ question. According to the principle of superposition, the amplitude of the resultant wave is given by scalar addition, algebraic addition, vector addition, and trigonometric addition. The correct answer for this question is C, that is vector addition. Next we have there are two waves of amplitude 4 unit and 5 unit respectively, which arrives at a point simultaneously such that the phase difference between the waves is 60 degrees. So what is the amplitude of resultant wave? Under root 61, 3, root 60, 61. The correct answer is under root 61. Let us see the solution of this question, like how it will become. Students, the solution is only, the purpose of the solution is only that if a student are doing mistake at any particular step, so they can do correct. The formula which we know, A is equals to under root A1 square plus A2 square plus 2A1 A2 cos theta, where A1 is equals to 4 unit, A2 is equals to 5 unit, and theta is equals to 60 unit, 60 degree. So we just put this value and get the result, which is under root 61. Now the topic is the coherent and non-coherent source of light. For the exam purpose, this topic is important for the 2 marks questions only, not for it at all. So what is the non-coherent and coherent sources of a light? Non-coherent sources are dash two sources of a light which frequencies are not same and phase difference between the waves emitted by the which does not remains constant. With with respect to time are defined as soon as the coherent sources. So firstly, I just want to explain this particular question. Non-coherent sources, which are not actually coherent, which are not actually linear in the nature. So what they are doing, they are just emit the lights actually that not are constant. They are maybe somewhere more, somewhere like light. So the light emitted by the two independent sources, candle or a bulb, is the non-coherent sources because the interference phenomena cannot be produced in two such cases. Student, these things keep in your mind, like this is a phenomena. Non-coherence is a phenomena which we are using in the candle for the burning and for the bulb, etc. But they don't have an idea about that why this kind of a things happen. So the intensity of the light or the position of the fingers keep on changing in scale. And because of that, the intensity of the light of the position fringes keep changing in 10 to the power minus 8 seconds. Now moving ahead with this topic, coherent sources. So this is the main topic of our this chapter. The two sources of a light whose frequency or wavelength lambda are same and the phase difference between the emitted by wave which is remains constant with respect to the time and defined as a coherent sources. Not only this, students, as you can see over there, we have frequency, wavelength, and phases. All these three are in the must be in the same phase. Otherwise, we can't observe this phenomenon. They are obtained from the same single sources. They can be apparent or real. Laser light is a highly coherent and monochromatic. The distance between them is small. Therefore, because of that, the state of polarization size is small. Next question we have. These sources are two waves. Spatial, coherent, temporal coherence. These two methods are obtaining for this. Division of method, division of amplitude. So the correct answer, as I told you, like these sources are two types: spatial coherent sources and temporal coherent sources. And the second is two method is a division wavefront and like division of amplitude. Division of a wavefront. If I'm just talking about division of wavefront, what is this, students? So the light source must be narrow. The first condition. The wavefront emitted by the narrow sources is divided into two parts by reflection or refraction. The coherent sources obtained are imaginary and Fresnel biprism and Layard the mirror, Young modulus data, etc. Division or of amplitude. Source light is extended. The amplitude of emitted by an extended source of a light is divided into two parts, partial reflection and partial refraction. The coherent sources are obtained by the real example Newton's ring, Michelson interferometer, colors in thin film. In a young double-slit experiment, 2 points of the wave's front are used as the coherent sources, whereas the Fresnel and by prism two virtual images. In layouts, one original source and its image are used as a coherent sources. Now let's move on to some MCQ question for more doubt clearing session, as we can say that. Laser light is a highly coherent, non-coherent, monochromatic, or both A and B. Both A and C. The correct answer for this question is both A and C, coherent and monochromatic. Next, Fresnel biprism, an example of a division of amplitude, division of wavefront, non-coherent of a source, non-division of these things. So the correct answer for this question is division of wavefront. Students, I hope you understand the complete phenomena of a coherent light rays. So till that, take care, student, and thank you for watching this video.